This is how tyres become hazardous to the environment. For within 70 years, tyre rubber breaks down into oil and other materials, polluting groundwater over long periods of time. In Germany alone, almost 600,000 tons of used tyres are generated every year. That's more than 30 million tyres. Only a small proportion of these are retreaded or used to fire rotary furnaces in cement factories. Most end up on rubbish dumps or are sold for export to countries outside the European Union. The lack of an economic recycling process encourages such disposal. However, the problem has been made more difficult by new EU rules requiring manufacturers to take back scrap cars and used tyres. Up to now, all procedures have been based on pyrolysis and required temperatures of over 1,000 degrees Celsius. They have several significant disadvantages. Poor cost efficiency due to the high energy costs and discontinuity of the process. The products of recycling cannot be reused in a cyclical manner. And they produce caustic, highly toxic pollutants. These disadvantages are now a thing of the past. A completely new kind of recycling plant can be found on the Eisenhüttenstadt industrial estate, 80 kilometers east of Berlin, near the Polish border. It's no coincidence that this is a worldwide project featured at Expo 2000. For it's here that BOS Sondermaschinenbau from Berlin and ABF have built a pilot reactor that uses the internationally patented Formex method. This can process up to 100 kilos of used tyres every hour. This special procedure revolutionizes traditional pyrolysis. The end product, carbon black, is of a high quality and can be reused in the rubber industry. The procedure is cost-effective too. Gas released during the recycling is used to heat the reactor. And the considerably lower temperatures reduce the production of dangerous substances. The centerpiece of this innovation is a reactor filled with liquid tin. This was developed and produced by BOS Sondermaschinenbau, a leading manufacturer of purpose-built machines and machine tools based in the German capital, Berlin. The shredded rubber is transported through the tin bath. The inside of the reactor is kept at a constant and strictly regulated temperature. A completely novel system of valves at the inlet and outlet ensure the reactor remains hermetically sealed. This is the sequence of events at the Eisenhüttenstadt plant. Used tyres are shredded and transported into a bunker. From there, the reactor is fed with the lumps of rubber. In the tin bath, the rubber is broken down into a mixture of gas and solids. A cooler is then used to separate the oil from the gas. The gas is pumped into a gasometer and can be reused to heat the reactor, while the resultant oil is collected in a tank ready for processing. After passing through the reactor, the various solids are separated out in stages. First, any remaining oil is removed in a degassing system. Then the mixture is cooled sharply for further processing. A magnetic separator removes the steel wire from the mixture. Tyres contain webbing known as textile cord. This is separated out by a tumble sieve. The final stage involves the use of a jet mill. This removes any tin particles which can be fed back into the reactor. All that then remains is carbon black, the aim of recycling. This is ground down to the desired size and packed. The end product consists of 30% carbon black, 35% oil, 19% heating gas, 15% stainless steel and 1% textile cord. The advantages of the Formex method lie both in its cost-effectiveness and the environmentally friendly process. The reactor is heated with waste gas. Additional energy is only needed during warming up. The ground carbon black can be reused. The oil is more valuable than crude oil, and the steel wire can be reworked as stainless steel. Because of the special procedure and the low temperature, only small amounts of harmful pollutants, such as dioxin, furane and benzopyrene, are produced. In 1995, the states of Berlin and Brandenburg awarded the patented Formex method their Innovation and Environmental Prize. The refinement and further development of this project is supported mainly by the German National Environmental Foundation. Its appearance at Expo 2000 is intended to introduce a worldwide audience to a procedure that is economically viable for operators, even without subsidies or other financial aid. An innovation which proves that economics and environmental protection aren't mutually exclusive. The novel pilot plant at Eisenhüttenstadt is used primarily to optimize the procedures. It also serves as the precursor of a plant that can process 3,000 kilos of used tire.